Let's try to understand hydrates, okay? So what is a hydrate? Well, hydrate is a compound that actually contains water in the chemical formula of the compound. So what does the chemical formula for a hydrate look like? Well, something like this. So let's go through it. This means we have barium chloride as a hydrate. We have iron 2 sulfate as a hydrate. Sodium carbonate as a hydrate. Copper 2 sulfate as a hydrate. So let's just look at this and see if you can see what the chemical formula of this hydrate would be. Well, what is the chemical formula of water? Well, it's H2O, right? And remember, the bent structure of water, right? Oxygen with 2 hydrogens, oxygen being partially negative, hydrogens being partially positive. So if you look, this is one water molecule. This is one water molecule. And this is one water molecule. So what else do we have besides water? Well, we have this and this and this. Now, when we're writing a chemical formula, what do we write first? The positive ion. So that's Ba, barium. How many bariums do we have? Well, you only see one. We're just counting with our eyeballs, right? And then what else? We have Cl. How many Cl's do we have? 2. We write that as a subscript, okay? And then we write this little times sign, a dot, okay? How many water molecules did we count? 3. And what's the formula for water? H2O. So that's just to give you a sense of what the hydrate formula looks like, what it comes from, okay? Now, we're going to get into the fact that we could do something to remove these water molecules and leave this behind. So keep that in mind. We're going to get there. All right, so what does this mean? So if I take, here's copper 2 sulfate. This is the formula for the hydrate. You can see it has water attached to it. And I heat it up, I can cause the water to leave, leaving only the copper sulfate behind, okay? Now, we did something similar in a lab with popcorn. So in a bag, we put popcorn seeds, we closed up the bag, right? And then we put it in the microwave, and then that allowed most of the popcorn to pop. So then we had popcorn kernels, right? Now we still had maybe some that didn't pop, but then we had all this popcorn. And when we opened the bag, you saw something leave. What left? Water. Okay, so this, in a similar way, we could put it in a container, typically a crucible, and heat it over a Bunsen burner. The water would evaporate and it would leave the other part of the hydrate behind. Okay, so again, if we take a hydrate, right, what we're left with after we remove the water is called anhydrous, meaning without the water. Okay. Now you're never going to have to come up with that vocabulary word anhydrous. Well, you may see the vocabulary word. Okay. So that means if you take any hydrate and you heat it, you can have the water evaporate out, leaving the anhydrous salt left. We can use this knowledge to find the percent composition of water. Here's an example. I have the images from the periodic table so we can get the atomic masses, because the formula for percent composition is the mass of the part over mass of the whole times 100. Remember, you find that on the back of your reference table, okay? So if I'm trying to find the percent composition of water, this is the part, and the whole is all of it. Okay, so I need to find the molar mass of the whole thing, and then I need to find the molar mass of just the water part. So let's do the water part first. Okay, hydrogen's atomic mass is 1, but I have 2 of them, so that's 2. Oxygen's atomic mass is 16, but 16 plus 2 is 18. So 18 grams per mole is the molar mass of one singular water. But I don't have 1, I have 10. So the molar mass of the oxygen and hydrogen part of water is 180 grams per mole. So that's the part. So that goes up here, 180. All right, now what's the whole thing? Well, now I need to find the rest. So I have sodium, that's 23, but times 2, right? That's 46. Carbon is 12, and oxygen is 16 times 3, which is 48. All right, now I need to add these up. So 48 and 12, that's easy, that's 60, plus 46 is 106 grams per mole for all of this. But that is not the whole thing. That was this, the sodium carbonate part. So what I need to do to find the whole thing is add these two together. So that is going to give me 286. So that's the whole thing, and then times 100. That will give me percent composition of water in a hydrate. Now, here's the thing. Sometimes they don't ask the question that way. They ask it in a way like this, where they give you the mass and say, you had this amount. In this case, you had 0.2116 grams of a hydrate. You heated it up. At the end, you had this amount. What is the percent composition of water? Okay, so think about the popcorn again. Okay, I take what I started with, right? 0.2116 minus what I ended with, 0.1353, and what left? The water. So the difference in these two numbers is the water. That's the part of the water. So let's just do this math. So that's 3. I gotta borrow all the way over here. Okay, so 6, 7, 0. So 0.763 grams of water. That's how much left as it was being heated. If you watched it closely, you would have seen steam. Okay. So mass of part, what is the water part? 0.0763. What is the whole thing? 0.2116 times 100. That is how you find the percent composition of water when you're given data like mass before and mass after the water left. Okay. So hopefully that helps you understand hydrates a little bit more and you can get through some of those difficult problems.